Hello everybody and welcome back. Root Beer here, going through the grade 7 Gauss paper from the year 2000. We're on question number 15 right now, so let's take a look at what it says. In the diagram, all rows, columns, and diagonals have a sum of 12. What is the sum of the four corner numbers? Okay. Now there's two ways I can think to do this question. The first way is the really obvious way of, okay, well, we know this column's got to add up to 12, so what's this number? And then we use that number to get this number to get that number to get this number, and then we've got all four corners. Or another way we can do it is we can say, well, these two diagonals have a sum of 12. Okay? So we immediately know what this number is. It's going to be 4, because 4 plus 4 plus 4 is 12. And although I don't know what these numbers are, I know they have to add up to 8. Because when I add them with 4, I need to get a total of 12. So these two corners add up to 8, these two corners will add up to 8, and so I should get a total answer of 16. So you can pick either way to do things. So I guess I'll just use a little algebra and show that last technique, because I think the first one is very straightforward. So we don't actually need the information of that 4 up in the top corner or the 3 that we're given. That's just for the other way to do it. And if you don't see this algebraic way of doing things, that's okay. That's really okay. You don't have to, but now you're being introduced to the idea. Hang on a second. Oh, yes, okay. For a second there I thought, well, B and C have to add up to 8, but that's not true. A and C have to add up to 8. As I say, if you don't see this method, that's okay, and even after I explain it, if it's not entirely clear, that's okay. Hopefully you'll progress in algebra enough that maybe you might understand the solution at some point. But I think it's an interesting way to do it, and obviously, if you're worried about it, there is the other way you can do it, where 3 and 4, so there's got to be a 5, and that's got to be a 3, and that'll have to be a 5, and that'll be a 4, and so you'll get a sum of 16 that way. But if we let A, B, and C be the other corners, so since the diagonals add up to 12, we have A plus 4 plus C is equal to 12, and B plus 4 plus that 4 up in the top right is equal to 12. So A plus C, if we rearrange this, we get 8 is equal to A plus C. And if we take this middle 4 and we subtract it off of 12, we get B plus 4. So all of these guys are equal to 8. What we want is the sum, A plus 4 plus B plus C. But that's just A plus C plus B plus 4. And we know both of these are 8. We just worked that out. So we get a final answer of 16. And I believe that was C. Yes, it was. So that's a nice way of doing that question. You might think it took a little while because I had to explain it and I had to write it up. But if this idea came to you, and hopefully if you see a similar question in the future, maybe you'll think, oh, is there a faster way of doing this rather than working everything out? Then hopefully it'll click in your head, and obviously your brain works faster than you can talk, and obviously faster than I can talk. So it looked more complicated and involved, but if it's something that jumps out at you, I think it can be a very quick way of solving this question. especially if it wasn't just a 3x3, maybe if it was a 5x5. This could be really quick to get the answer. Alright, so that about does it for that question. And we'll take a look at question 16 in the very next video. So as usual, thank you so much for watching, and feel free to like the video if you enjoyed that method of adding up the corners without figuring them out.